coders! Today, we're building a hash table in Java using chaining with linked list. This is a core data structure that every developer should understand. So let's break it down line by line. No fast forwarding, just pure clarity. Let's go. In the line 1 here, so first we import the linked list from Java standard library. Why? Because every bucket in our hash table will be a linked list to handle collisions. If two keys land in the same bucket, we'll store them in a list instead of overriding them. That's called chaining. In the line 2, next, we define our main class, hash table example. This is where all our code will live. It's public, so it can be accessed by the Java runtime when we run our program. In line 3, line 4, in this line, we now define a static inner class called hash table. Static means we can use it inside our main method without needing an instance of the outer class. This is the actual class that will implement the hash table. So the next line here is we declare two private variables like size and buckets. So the size, this is how many buckets our hash table has. So in the bucket, this is an array of linked list string where each linked list holds strings that hash to the same index. Think of this like having an array of folders, and inside each folder, you can stick multiple pieces of paper or string. In next line here, this is the constructor for our hash table. When we create a new hash table object, we'll pass in the number of buckets we want. Next line, that line. So assume that we assign the value pass into our class internal size or variable. Next, that. And then we create the array for the buckets. But remember, the buckets themselves, the linked lists are still null at this point. We'll fix that next. In the next line, here we go. We loop through each bucket in array and initialize it as a new empty linked list string. This means every folder now has an empty list ready to store item. In line 15, in next line here, in that line, time for our hash function. This will make a string and turn it into an index where it should go in the bucket array. Next line is int and hash. So this is a simple additive hash function. We start at 0 and loop through each character in the string, adding its ASCII value to the hash total. So example, dog equals D plus O plus G. Dash 100 plus 11 plus 103 equals 314. The next line is here. Return hash modulo size. So we take the total and use modulo to keep it within the bounds. This is the modulo, guys. That's a modulo. To keep it within the bounds of our array. If our size is 10, this will return a number from 0 to 9. Example, 314 modulo 10 equals 4. in line 21, the public void insert string k. So that method inserts a new string into the hash table. The next line, index hash key. First, we call our hash function to figure out which bucket or folder to use for this key. Next line, if. So before adding the key, we check if it's already in the bucket. This avoids duplicate values. If it's not in the list, we add it. The next is the public void display. So this method prints out the entire hash table, bucket by bucket, so we can visualize what's inside. Next line, this line. Key sa null. Connect. So we loop through each bucket, and for each one, print the bucket number. Print every string in that bucket. Use this to show chaining, and with null to represent the end of the chain, just like in linked list diagram. In line 35, public static void. That's our main method, the entry point of our program. Next is the hash table. We create a new hash table with 10 buckets. So our bucket array goes from index 0 to 9. Next line is the string. So here's our test data, an array of strings that will insert into the hash table. Notice these are mostly anagrams. They're likely hashed to the same bucket. Next line is for we loop through each key and call the insert method to put it into the hash table. The next line is the table. Finally, we call display to print the whole table and see how the keys got distributed among the buckets. So here are the output sample. Let me show you guys. Here you can clearly see that the cat, the tack, and the act ended up in the same bucket. And also the dog, god, and ODG are in the bucket 4. Ended up in the same bucket. Their anagrams and the same ASCII sum.